Hi there. So I'm going to be going over another projectile motion question. Let's get started. This one is Jeannie Gold, wedding planner extraordinaire, decides to shoot confetti pellets into the air at an angle theta above the horizontal from a point 80 meters above the ground. The question is, if the vertical component of the initial velocity is 30 meters per second upwards, how long does it take the projectile to land? So we can start off by drawing a diagram of what's happening. So if this is a platform where she's standing, and that is 80 meters above the ground, and if these are her pellets that she's shooting, and let's say they follow a trajectory like this. All right, so what we want to do is find the total time where the pellets leave her hand all the way to when they hit the ground. So to do this, we're going to break up the travel time into separate sections and then calculate them for each section, then add them all up together. So if we redraw the trajectory, we can calculate the time it takes for the pellet to become level with the platform that it's getting shot off of. We can denote that as TL, and then calculate the time it takes for it to just fall straight down, which is, we can denote this as TC, C for the cliff. All right, so let's get started and calculate just the time it takes for it to become level with the platform. So to go about this, we could look at the level ground formula for time, which is 2v sine theta all over g. But the problem here is, of course, we don't have theta or v. So we have to resort to our old way using our old kinematics formulas. So in this case, what we want to do is actually just calculate the time it takes to reach the top. And because this is symmetrical, the total time from here all the way to here is just going to be 2 times that. So first, let's calculate this t half, and then just multiply it by 2 to get the total level time. So if we do that, we know that VF is equal to 0, and VI is given as 30, and A is just equal to negative 9.8 meters per second, and time is what we want to find. So of course this one looks like the best formula to use. VF is equal to VI plus AT, and let's plug these values in. So we get 0 is equal to 30 meters per second plus negative 9.8 meters per second squared times t. And if you do this, what we get is actually minus 30 meters per second all over negative 9.8 meters per second squared equal to t, and that gives me 3.06 seconds for t. And remember, this is t half. So if we want to multiply it together by 2, we get TL is equal to 6.12 seconds. Okay, so the next thing we want to do is to find the time it takes to travel from the cliff all the way to the ground. So to travel that 80 meters. Okay, so let's make a list of what we do know. So we know that the distance is going to be equal to a minus 80 meters. We know that velocity, the initial velocity, so the velocity right here, because it is symmetrical once again, so it starts at 30, goes to 0, and then it'll come down back to 30, so, but just minus 30, of course. And then A is equal to negative 9.8 meters per second squared. And what we don't know is time, of course, and we also don't know the final velocity. So let's look at the potential formulas that we could use to solve for t. So these include d is equal to vi times t plus 1/2 at squared, and then vf is equal to vi plus at. So these are the only two that we have. So if we look at the first one, we don't want that because t appears in both terms and we don't want to end up solving a quadratic. So that leaves us with this formula here. So if we go through this, we have VI and we have A, and T is what we're trying to find, but we don't have VF. So we have to go in and figure out VF, then plug that into here and solve for T. So the only remaining formula is this. So VF squared is equal to VI squared plus 2AD. So we can solve for VF using this formula and then plug that into here. So let's go ahead and do that. So we can solve for VF by using this formula, and VF we can just take the root of this. So it's going to be square root of VI squared plus 2AD. And because it is pointing down, we're just going to take the negative root of that. So then this becomes negative square root of minus 30 meters per second squared plus 2 times negative 9.8 meters per second squared times negative 80 meters. Okay, if I plug that all into the calculator, I get negative 49.68 meters per second for my VF. Okay, so now we can grab this value and plug it into this formula over here and solve for T. So if I just rearrange this to just isolate T, what you get is you're going to move the VI over and divide by A. So this becomes T is equal to VF minus VI all over A. And this becomes VF is minus 49.68 minus 30. Oh, it's minus 30 because it's negative as well, all over negative 9.8. And that gives me 2 seconds. All right, so this time is the cliff time. So remember from before, what we want to find is the total time. So the time it takes to be level and then all the way to when it travels that 80 meters to the ground. So total time is equal to TL plus TC. So that's going to be equal to 6.12 seconds plus 2 seconds from this one. So that's going to give you 8.12 seconds as your total time. And that is your final answer here. Okay, so that's how you do this question. The key thing here is to split up the time into components and then find them separately. So find this section and then find this section separately and then add them up together. Yes, so thank you so much for watching. I hope you liked it and I hope this helped. And if you have any questions or comments, leave them below. Thank you.